Howdy folks, I'm David Brown. It's great to meet you all. Feel free to talk to me after the presentation. I'm from Fractal. We're a consulting firm. We do a lot of business with Microsoft, with NVIDIA, managing deployments and helping customers reach enterprise scale, managing deployments successfully and supporting those deployments in an ongoing way. Our background is in more of the traditional cloud and machine learning technologies, but we've been running hard and fast to keep up with all the innovation that's occurred. One of the things that we've seen as a common pattern that we've incorporated into our internal accelerator program to assist with asset-based consulting and delivery engagement is the idea of an aggregated retrieval augmented generation pattern in order to produce superior results from an LLM perspective when it comes to user interface. So today I'm going to be talking about the design pattern that we're seeing, some of the useful tools from NVIDIA and some of the useful tools from Azure that we're leveraging to do that delivery and innovation. AggRAG is the name that we've given internally to this pattern, use of many retrieval augmented generation services deployed together, some adversarially, some in concert, working to provide enterprise scale, highly effective, customer-focused LLMs, and that's what we're talking about today. These deployments can support a wide range of use cases. They can scale pretty easily. When it comes to the individual, cloud components, these are definitely optimized for the cloud. The recent kind of advent of 5.3 and some of the small language models means there's going to be potential for hybrid cloud architectures and deployment to the edge. But today, pretty much all of these tools are focused on the cloud, and we're leveraging them within the context, particularly of the case study that I'll be presenting within the context of Azure. We presented at GTC. This is a link to the GTC presentation. This outlines some of the challenges that we're seeing and why we leverage adversarial models, why we leverage multiple RAG patterns working in concert in order to provide superior delivery. These patterns and this pattern I'll be presenting scales to multiple use cases. It engages in some of the reliability, temperature, and context issues that oftentimes you run into with LLM deployments. This architecture that we've developed is designed to scale to and support multiple LLMs in production and scale to all the new LLM and RAG releases that are being made, all the new technologies. One of the central pieces that we've kind of leveraged is, in addition to other cloud components, is Azure Cosmos DB. There's been some exciting announcements just a few hours ago from them on what their database can support. And what we view this as is a reliable way to package and deploy LLMs at scale. So with that, I'll step through the architecture here. There's a few kind of differentiated components that I'd like to call your attention to. The first is use of guardrails. These are adversarial models that are deployed in order to increase quality, as well as other subroutines, other systems that are designed specifically to maintain and manage model performance when deployed in production. We're using NeMo's guardrails for a couple of different things. One is I/O, which is input-output, and making sure that the model is being throttled appropriately so that we're not getting random spam coming into the model. On the other side of things, we're also using retrieval guardrails in order to ensure that the model is working effectively and safely within the constructs that we've created. Oftentimes, we're deploying these guardrails alongside of the Azure AI Studio tools and leveraging those components in concert to produce a superior system. Oftentimes, with this architecture, we're supporting a host of different LLMs working together. And that's where a lot of the unique design components come in from a best practices perspective. We're engaging in intelligent conversation design, leveraging tools like LangChain and other models in order to handle specific context switching problems, subdomain problems, and build out a tree-based response system. So that's the high level. How we went about creating this system is through the process of evaluating data input, handling generation and caching, creating a system that in an ongoing way handles model evaluation and incorporates that feedback in. The two key tools that we use to create this are the build.nvidia.com asset library and Azure AI Studio, which is accessible here via the azureai.com/build URL. We see this application, this architecture being scalable to a host of different potential applications. And so, if you want to dive deeper on what your business is trying to do, happy to talk about some of the areas of impact we're seeing, talk about some of the customers that we're engaging with, and dive deeper. So thanks, everyone.